Okay, so this is chapter 2, section 6, and it's all about rational exponents. Excuse me. Okay, so there's some things that you should know if you don't already know. You know how, like, multiplication and division are opposites of each other? Addition and subtraction are opposites of each other. Well, exponents and roots or radicals are also opposites of each other. So these are inverse operations. Okay. So you can undo a root with an exponent, or you can undo an exponent with a root, right? So if I have, for example, you know these to be true. 4 squared is equal to 16. And then if I take the root of 16, that equals 4, right? So those things can be undone. And if I were to take the root of 16 and simply square it, these two things actually cancel each other out and give me just the 16 underneath of here, right? So that is actually a valid statement, okay? So it's important to know that these are opposites of each other. Roots and exponents are opposites of each other, all right? So there's a lot of rules that can help us not only deal with and solve exponential problems, but also solve problems with radicals. So we're going to make a big giant list, and then we're going to use some of them. Okay, so over here we're going to make a list of exponential rules. And I'll try to give you an example as we go. Okay, so the first one is your product property. And the more you know about vocabulary in math, the more these are going to make sense. Product means multiply, right? If you don't know that, you should write that down. I'm not going to because I know that. But what this looks like is a to the m times a to the n. So I'm taking a base to a power and a same base to a different power. And I would end up adding those two powers together. So here's an example. I'll put the examples in black for each of them. Okay, if I have x to the third times x to the fifth, that would be x to the 3 plus 5, and I would get x to the 8th. Okay, so the rule is in purple, the example is in black. Next one I'm going to do is in orange. This one is called the power property. Okay, this is when you have one base and you raise it to a power, and then you raise that to a second power. Well, these ones, you multiply together. Okay, so this would look, let's use the same numbers that we used in the last one. If we had x to the third and we raised it to the fifth, now we're going to multiply x to the 3 times 5, and we're going to get x to the 15. Okay, so that's how you would use that power. All right, the quotient property. Quotient means the answer to a division problem. So again, if you know what these words mean, it will help you make a little bit more sense out of things. You guys, my dogs are in the other room. There's 4 of them, and one of them just passed some serious gas. Like, I could hear it from the other room. It's kind of embarrassing for them. All right, so quotient property. So this looks like a to the m over a to the n. So again, same bases, different powers. This is going to be a to the m minus n. And so, example, we'll continue to use these same values. Okay, so we'll go, I'm going to switch these around. I'm going to go x to the 5th over x to the 3rd. This is going to be x to the 5 minus 3. It's always top minus bottom. So this will be x to the 2nd. Okay. Quotient property. All right. I don't know if I can extend this page. I don't know why I can't do that. Let me try to do something here. View, zoom, entire page. Now can I zoom down? Oh, that didn't work. View, zoom, page width. Whoa, that's terrible. Sorry. Bear with me here a second. Maybe I should just go undo. Undo. Will it undo a page width? Maybe it won't do that. Oh, it's undoing my writing. All right, well, I guess that's the best I'm going to get. So I had a to the 5th over a to the 3rd. Sorry, you get to take a break for a second. All right. Okay, so number 4 is the negative exponent property, but I'm going to do that one on the next page. So this one is going to be the negative, what's this, number 4, right? Negative exponent property. Okay, and we're going to give you 2 examples of this one. So 4a looks like this. A to the minus m equals 1 over a to the m. So it becomes a fraction and the power becomes positive. All right, here's an example. So if I had 9 to the minus 2nd, that would become, we would just flip this thing and put it under 1. And then you would have to evaluate this. Well, 9 to the 2nd is 81, so 1 over 81. And that would be your answer to that. Okay? Well, here is B. Sometimes you're going to be given a fraction, and that whole fraction will be raised to a negative exponent. Well, if that happens, I want you to flip the fraction, the whole thing. Okay, so this is now going to be B over A. So this part gets flipped. Right? And now the M is going to be positive. Okay, so here's how an example of this would look. So if I had something like 3 over 4, and this was raised to the negative 2nd power, I'm going to flip this. So this is going to go to 4 over 3. Power is going to become positive. And all this means when you were to do this, you would now go 4 squared over 3 squared. Well, you know 4 squared is 16, 3 squared is 9. So you get 16 over 9. Okay? That's how your negative exponent property is going to work. It's going to come into play a lot. You're going to need that a lot. You should star this thing. You should highlight it. I'm going to highlight it. You should highlight it. Oh, that's a wrong highlighter color. I meant to do this. There we go. All right, and then the next one you're also going to use a lot. And we'll give you an example of how that guy's going to work also. So one more page. I'll go back to a pen. We're going to have the rational, I guess this is number 5. Rational exponent property, or the rational root property. It could be called either one. So it's going to look like a to the m over n. So it's a fractional exponent, okay? And what you're going to do with that is turn it into a radical. So it's the nth root, where a is the base, and then you're going to raise it to the m power. Okay, so here's an example. So we're going to take 4 to the 3 halves. So we're going to take, what you need to be able to do is know what your a, your m, and your n are. Okay, your a is clearly this big number. So the 4 is going to go under the radical. The m is the top number. That's going to go outside the parentheses. And the 2 is the index. That's your n. So that's going to go in there. Okay, now you're going to evaluate. So what's the square root of 4? This is the part you would do first. Okay, well, the square root of 4 is 2. And now you're going to cube 2. And 2 cubed, that means 2 times 2 times 2, right? That's 8. So 4 to the 3 halves, weirdly, is equal to 8. Is that not strange? All right, so you're going to use that, all 5 of those, in this varsity to go back and forth between some things. There's going to be variables in there. It's going to be a little outside the box. I'm going to tell you that right off the bat. Okay, so please, again, don't suffer in silence. Come get help if you need help. Advocate for yourself. Let me know that you're struggling. It's my job to help you. That's what I want to do. So, also make sure your note numbers on the side. This is 2.6. Rational exponents. There are so many different examples of these. I cannot cover all of them, so I'm just going to give you the rules, give you the properties, and then see what you can do when you get to the varsity. Okay? All right. Toodaloo for now.